Hello everybody, this is Math 1 for Day 4. We want to talk about polynomials and especially quadratic polynomials and then how to factor them. So beginning with polynomials, we're branching out to make it a bit more complicated because there is not just one power of x involved, but many. This is what the poly means in polynomial. But we also make it easier because the exponents will only be positive integers, 0 at most, but no nonsense with fractional exponents here. So first, polynomials. Best viewed by way of example, I think. So here's a couple. X squared, x squared plus 4x minus 9, x cubed minus square root of 2, x to the 7 divided by 8 plus x to the 6 times 11 minus 4x plus x squared. So, bunch of examples, and I have a few comments. The first one, I would call in standard form. That is, the powers of x begin with the biggest one, and then the exponents gradually go down. You've got lower and lower powers of x. The second one is also in standard form. And the third one, on purpose, is not in standard form because I've got this x squared at the end, which by rights should belong in between the x to the 6 and the 4x, so not in standard form. And that's an obvious thing that you can line those ducks up in a row. You can write every polynomial in standard form. Another thing which is not quite standard about the last example is x to the 7 over 8. Not quite standard. Rewrite it as 1 over 8 times x to the 7, and then plus 11 times x to the 6 plus x squared minus 4x. So I have placed the x squared in the spot where it belongs. I have moved the 11 in front of the x to the 6. And I've rewritten x to the 7 over 8 as 1 over 8 times x to the 7. So every term is a constant times a power of x. And there's only one variable. I want to keep it to one variable today. And the constant is written in front of the power of x, not behind it. It's just really something you want to have standardized. So we can compare polynomials and see at a glance whether two different looking polynomials maybe are actually the same or not. All right, so two terms about polynomials are the degree of that polynomial. Give it a nice box. The degree is the highest power of x in that polynomial. To be specific, the highest exponent. Looking at my examples, the first example has degree 2, the second one has degree 3, and the last one has degree 7. So degree 2, degree 3, and degree 7. And the last concept of polynomials in general is the leading coefficient. Well, it's that constant next to that power of x after you wrote it in standard form. So go through the list of examples. First example has an invisible 1 here. This is what whenever you don't see anything, we can imagine that there's a 1. Okay, so that's a leading coefficient 1. Same thing in the second example. And the first example, you better write it in the standard form first. And then you can see it's 1/8. One, and 1/8 are the leading coefficients. Easy enough to spot for every polynomial. And because this video has already been going for a while, we just draw a line here and go to quadratic polynomials in the next video.